Hello there. Today we're going to talk about finding the probability for independent events. Yesterday we talked about simple probability. Today we're going to talk about compound probability. The difference is simple probability is when you're finding the probability of one event. Compound probability is when you're finding probability of two events and then combining them to figure out the odds of both of them occurring. So it would be like flipping a coin and rolling a dice. Not only would you have to land on heads on the coin and perhaps a 3 on the dice, you'd have to find the probability of both happening. And as you can kind of consider that, the odds are going to get very small. They may not be in your favor. Little shout out to Hunger Games. So our keywords here are with replacement, simultaneously, and the word and. That may sound a little silly, but replacement means that, let's say you are working with pulling marbles out of a bag. If you pull one and then replace it, you have not affected the probability of the second event occurring. If you do not replace it, then you have affected the probability. We will talk about that tomorrow. That would then be a dependent event. So we call events independent when two things are happening or two probabilities are being considered and the outcome of one has no effect on the outcome of the other. For example, it would be like rolling a number cube and flipping a coin. Rolling the cube has no effect on flipping the coin and landing on either heads or tails. Therefore, they are independent events. To find the probability of two independent events, you're going to multiply the probabilities of the events. So for example, this is just some notation. Don't get caught up on the A's and the B's. The probability of A and, there's that word and, B happening. And is a buzzword for compound probability. So let me circle it for you. Probability of A and B happening is going to be equal to the probability of the first event, which would be like rolling the number cube, times the probability of the second event, which would be like flipping the coin. So when rolling two number cubes simultaneously, that's a buzzword, what is the probability of landing on a 3 on one cube and a 4 on the other? So both things have to happen for you to win this game if it were a game. To find out what your odds of that happening, they're quite slim. The probability of landing on a 3 and a 4 is equal to the probability of landing on a 3, which is 1/6, times the probability of landing on a 4, which is also 1/6. So you'd have a 1 out of 36 chance of that happening. I wouldn't put my money on that. Let's look at some examples. So those 6 number cubes represent one number cube. I just want to show you what all the possible outcomes are. And then we have a spinner. Now the spinner is divided equally, but if you look at the different colors and their odds of happening, they're not distributed evenly. So that's something to consider. So if we were to find the probability of landing on a blue when you spin the spinner and rolling a 2 when you're rolling this dice, we would take the probability of landing on a blue, that's 2 out of 5, and multiply it by the probability of rolling a 2, which is 1 out of 6. So the odds of both of them happening are 2 out of 20. Remember, multiplication is as easy as a piece of pumpkin pie. Across the bottom and the top, you multiply, then simplify. You have a 1 out of 15 chance. Let's look at the next example. What about the probability of spinning a yellow and landing on an even number? So your odds of landing on a yellow aren't that good. Only 1 out of 5 of them are yellow. But because you can roll an even number, you've got 2 or you roll with 4, roll, whoops, go a little crazy there. Where are you? Or you can roll an 8. Sorry about that, my computer is a little lagging. So you've got a 1 out of 5 chance on a yellow, but a 3 out of 6 chance to land on an even. So to find the probability of both happening, you take the probability of the first, 1/5, multiply by the probability of the second. We get 3/30ths, which we can reduce to 1/10. Okay, I'd like for you to try on your own questions 3, 4, and 5, and then we will check them. Please hit pause and do that. Okay, for number 3, probability that you select or land on something that is not blue, that would be a red, or yellow, and our other red. The odds of that happening are 3 out of 5, and probability will land on a 5 is 1 out of 6. So we have a 3 out of 4, 2 out of 5 are red, 1 out of 6 are 4, so we have a 2 out of 30 chance or 1 out of 15 chance. And for number 5, probability of blue, that's 2 out of 5, and 5 out of 6 of those sides are not a 2. So the odds of not landing on a 2 are pretty good. Probability of both of 10 out of 30 are 1 in 13. So pretty good odds there. All right, so now we'll look at our probability of flipping on a coin and rolling a dice. So they want us to find the probability of landing on heads. One of two of those sides is a head, and landing on a 3 on a die. By the way, this is notation that you will often see. This uppercase P just means probability of, and then what's in parentheses is what. They want you to find the odds of happening. That's the notation that they'll use. So the probability of both would be 1/2 times 1/6 or 1/12. All right, let's talk about a standard deck of cards. We often do sorting in partner groups with cards, but every deck of 52 cards has 4 suits. There's the diamond suit, the red diamonds, and there's numbers ace through king in our diamond suit. There's our spade, there's ace through king in our spade suit. We have our clubs, there's ace through king in our clubs suit and our hearts. And the same is true. So since there are 13 cards in every suit, we can multiply 13 times 4 to determine how many cards are in a standard deck. This does not include jokers or any of the miscellaneous cards in the deck. There are 52 cards all together. So 13 of which are diamonds, 13 of which are clubs, 13 are spades, 13 are hearts. And then you have one number, for example, the number 5, there would be 4 5s. 1 spade, 1 diamond, 1 1 heart, and 1, what's the other one? Club. So we wanted to find the probability of choosing a jack and an 8. And is that buzzword that lets us know we're multiplying. Well, 4 out of 52 of those cards are jack because there's 1 in every suit. 4 out of those 52 cards are an 8 because there's 1 in every suit. So, whoa, the odds of pulling both a jack and an 8 are not good at all. You multiply the two together, and then I did reduce that. It would reduce to 1 over 169. So I want you to take a few moments to do the next 2 questions. And one pertains to probability with marbles, and they want you to find the probability of a green and a yellow based on what is in the bag, and then the probability of students who like pizza based on the information that they give you. please press pause and do that. Okay, so in our jar, there's some important words that are highlighted and colored in red because they represent independent events replacing it. If I did not put the marbles back, I would have affected the probability of the second pull, and that would be a dependent example of dependent events. But these, we would put it back, so we have the same odds of pulling a green as we do pulling a yellow. Well, not the same odds, but the number of total marbles in the bag has not changed because we put it back. So probability of a green, 5 out of 16 of those marbles are green. 6 out of 16 of those marbles are yellow. So the probability of pulling a green and a yellow, if we do 2 pulls, one after the other, and after putting the first one back, you have a 15 over 128 chance, and that ratio has been reduced. A survey found that 9 out of 10 students like pizza. So if 3 students are chosen at random with replacement, so you chose one, you put them back in the class. You chose another, put them back in the class. You could very well be pulling the same person randomly because you're putting them back in the set. What is the probability that all 3 students like pizza? We've got 3 students that we're choosing. Each time the probability is the same because we are replacing that student. So we have a 9 out of 10 times 9 out of 10 times 9 out of 10, 729 over 1,000 chance. Pretty good odds that we will select 3 students who like pizza with replacement. And we'll just look at one more example. They're independent events because the outcome of one does not affect the odds of the second event happening. And since there are, let's see, how many green, choosing a green, 5 green, 10 white, so that's 15 marbles altogether. 5 out of 15 are green. You have a 1 out of 2 chance of landing on heads. Probability of both of them happening when you multiply is 1/6. And then red and heads, when a bag is containing 5 red and 5 white, you have a 1 out of 2 chance of getting a red, 1 out of 2 chance of landing on heads, 1 out of 4 chance of them both happening. So thanks for tuning in to our notes on independent probability. The biggest takeaway is that 2 things are happening. You're either reaching in the bag twice, you're flipping a coin and spinning a spinner. That's what makes them compound, because one event does not affect the outcome of the other. That is what makes them independent. So if you have any questions, please feel free to ask and complete your practice on this.